All right, looks like you made it to section 2. Excellent job. On section 2, we will be talking about something called dilations. The first question is asking you to write down what is a dilation. So let's write the definition of it down first, and then let's talk about what it really is. So if you could write this definition down, a dilation is a transformation in which a polygon gets bigger or smaller by a given scale factor around a center point. Please press pause if you need to copy this down. Once you're all set, go ahead and press play and I will move on. So when you hear the word dilation, you probably think of getting your pupils dilated. And when you get your pupils dilated, it means that the pupils become enlarged. So I'm about to show you a picture of a person who got his pupils dilated, and one pupil had a much greater reaction to the eye drops that dilate his eyes than the other did. So I just want to give you a heads up. It is a little kind of freaky looking when you look at it. So I just wanted to warn you before I switch to the next page. Okay, so if you look at the right eye, this is slightly dilated. And then if you look at the left eye, it is extremely dilated. His pupil is very large here. And if you were to compare the sizes between these two pupils, what kind of a comparison would you have between the two sizes? Think about that for a minute. Not even a minute, for a few seconds. Okay, so if I were to compare the sizes, I would say that this pupil is about twice as big as this, or 2 times as big as this. You might say maybe 3 times as big as this. It doesn't matter how many times bigger you think it is. It's just the idea of what the comparison is between the sizes. Now, if I were to draw right here what an actual normal sized pupil would look like, maybe it would look something like this right here. So that would be about a normal sized pupil. So if you were to look at this dot right here, if I were to compare this dot to this pupil right here, I would say that this is probably maybe 8 times bigger, 7 times bigger, 5 times bigger. Again, I'm not as concerned about the actual number, but here's the key thing that you need to understand. Every time I compare the sizes, I'm talking about one pupil being a certain number of times bigger, which implies that the type of operation that you have to do is multiplication. So let's go ahead and fill in where it asks you how do you do a dilation, exactly what we said. You multiply each coordinate by the scale factor. And this right here is key. The fact that you are multiplying is extremely, extremely important. Okay? Again, press pause if you need to write this down. Now, here's the thing that you need to understand, that when you do a dilation, sometimes it gets bigger, but sometimes it also will get smaller. So when I multiply by a scale factor of 5, for example, my picture will be 5 times bigger. If I multiply by a scale factor of 1/5, for example, my picture won't be 5 times bigger, it'll actually be 5 times smaller. Okay, so whole numbers will change it into, or sorry, numbers that are greater than 1 will make it larger. Numbers that are less than 1, between 0 and 1, will make your picture smaller. All right, so we're going to do one question together. And that question is number 1. So let's go ahead and read through what it says. It asks you to graph rectangle Oleg with the following coordinates. And then it asks you to graph Oleg prime after a dilation. This is really important right here. A dilation with a scale factor of 2. All right, the 2 is extremely important right here. So let's go ahead and do what it asks us to do first, which asks us to graph this rectangle. So I'm just going to go through and graph out all 4 of my points. So the first coordinate is -3, -3. So I'm going to go to the left 3, down 3, put a dot there. That right there is my O, right here. Then I'm going to put a dot right at -3, 2. I'll also put a dot at 1, 2. And then I'll put a dot at 1, -3. So then I need to make sure that I label my coordinates. So this is L, this is E, and this is G. Okay, and then you need to connect your dots so you have the actual rectangle. So I'm going to go ahead and connect my dots right here so I can have my rectangle. All right, now here is where you need to pay close attention because this is how you do the actual dilation. Remember, to do a dilation, you are just going to multiply each coordinate by the scale factor. So if the scale factor is 2, I'm going to take each coordinate and multiply each one of them by 2. I'm going to make them twice as big, just like the pupil was twice as big as the other pupil. So if O was -3, -3, that means that O prime would become -6, -6. All right. And then if L was -3, 2, that means that L prime will become -6, 4. Please press pause and see if you can get E prime and G prime. And then when you finish doing it, compare your answers with mine to see if you got the right answers. Okay, so E prime would be 2, 4, because I'm just going to multiply each one of these numbers by 2, and then G prime would become 2, -6. All right, all I have to do now is graph out my new rectangle. So I'm going to graph out O prime. I'm going to put it right here at -6, -6. L prime is at -6, 4. E prime is at 2, 4. And G prime is at 2, -6. And then I'm going to label them with my primes. So this is O prime. This is L prime. This is E prime. And this is G prime. All right, now all I have to do is connect my points, and I will end up getting my new rectangle, which should be twice as big because the scale factor was 2. There we go. All right, ladies and gentlemen, we are looking at the properties of dilations. And if you remember, the 3 properties that we discussed were shape, size, and orientation. And what I want you to do is press pause, see if you can figure out what happens to the shape, the size, and the orientation of a dilation. Are these 3 things preserved or not preserved? Please figure it out on your own, and then when you're ready to check to see if you're right, come back and check with me. All right? So for shape, here's an example right here. If you look at this triangle right here, when it was dilated, it was the exact same shape. It looks exactly the same, it's just bigger. So it would make sense that your shape is preserved because it stayed the same. All right, so we're going to say for this guy right here that the shape is preserved, okay? And then for the size, if you look at it, I mean, that's the definition of a dilation. If something's dilated, then it's an enlargement or it's shrunk. So the size is never preserved when you do a dilation. So we'll say not preserved. And then when you look at the orientation, look at the order that the letters A, B, C are going in. These are going in a direction that would be considered counterclockwise. And so are the primes right here. So A, B, C prime are also in a direction that's going counterclockwise. So here we're also going to say that the orientation is preserved, okay?